Here we go, folks, with normal distributions, example number 6. All right, very similar to number 5 in terms of its logic. But we're told that the scores on a college entrance exam are normally distributed. So here we go again with that bell curve. All right, normally distributed. We are told that the mean is 80 and the standard deviation is 8. They want to know if we're only going to allow the top 15% to be admitted into this college, what would be the cutoff score? So the cutoff score is, again, a value of x. It's one of these numbers across the bottom here. That's a score. And if you're going to be in the top 15%, I would hope you'd agree you would need to be above the mean. So this is where that cutoff score would exist. And wouldn't this be the top 15%? So I think here we go. We've got a upper tail of 15%, 0.15. That's the top 15%. If you score at or above this score, you'll be admitted into that college. So I think that's a pretty straightforward logic there, top 15%. So I like to draw the corresponding z picture where we've got a standard normal, and let's find the corresponding z-score that would create this upper tail of 15%. So, we always have to put it into that language of z. We've got to have things in standard form. Now, hey table, got a picture, upper tail 15%. This table doesn't do tails, all right? There are tables that do tails. But in your materials, I gave you this middle sliver tail that I would like you to use. And the table says, table not do upper tail, table want middle sliver. We always need to remember that this table always wants this region between here and here. So much like the one we did minutes ago, depending on when you watched it, wouldn't we want to take the upper half of that bell curve, 0.5, you always remember half is up here, half is down here. If we take that upper half of the bell curve, 0.5, and subtract that upper tail, 15%, we would discover that that middle sliver is 35%, 0.3500. Those extra zeros are there because I want to remind you that this table takes these areas, these probabilities out to 4 decimal places. As a mathematician, it kind of bugs me to leave those extra zeros, but anyway, I need to for this. Now, look in the body of the table, and I'll just remind you, as the z-scores get larger, like reading a book, so do the probabilities, so do the middle slivers. So it's not a random thing. And so 0.3500, as I see it, I know it's hard for you to see, but look at the one that I uploaded. But I believe that 3485 and 3508 surround it. And in this continuum here of z-score, or probabilities, pardon me, that would fall in that area. If you subtract these, that's 15. If you subtract these, it's 8. It's closer to this one. So we'll go with the 0.3508. And so 0.3508 lines up here as 1.04. All right? So that z-score needs to be 1.04 standard deviations. Above the mean, it's positive, right? If you're going to be in the top 15%, you have to score above the mean. So no coincidence that came out to be positive. Oh, so if you score 1% on the test, you'll make it into that college. Wah, wah. That's not the score. That's the number of standard deviations. So here again, just like the one we did earlier involving the warranty, again, please watch these in sequence because I build as we go on each one. But let's change that z-score into an actual test score. This is our translator. Hello, I translate between z and x. So again, if we put that 1.04 in for z, and then x is the unknown test score that we're looking for, and then the mean is 8, and the standard, or 80, and the standard deviation is 8, and then guess what? It's just algebra. Solve for x, all right? Algebra was a prerequisite for this course, so I've got to do this part pretty quickly. But I hope you would agree. I know a guy that screams, clear fractions! And you would multiply both sides by 8 over 1. 8 over 1. Those 8s cancel. That gets rid of the fraction over there. That's why we yell, clear fractions! And over Right here, we take this times this, and I believe that ends up being 8.32. And then, of course, easy, just add the 80 over. And X turns out to be a test score of 88.32. Test score. Points. I don't know what it is. Percentage points, score. Let's just call it that. So what we're saying is that any person who takes that test, if they score at 88.32 or above, they will meet the requirement to be admitted into that particular school. So there you go. I wish I had a math formula as to where to tell you to put the X. I don't. You got to use logic. So anyway, hope everybody's doing okay. Hang in there. Stay normal. We're going to be good.